Probability with multiple events. Here we go. Okay, so when the occurrence of one event affects how the second event can occur, the events are dependent. So one depends on the other. This would be like if I said, I'm going to pick someone's parents, and then depending on whose parents I pick will be a kid. Or if I pick a kid, and then I'll pick one of those parents, that depends on who I picked for the kid first. Independent means that there's nothing in common between them. Be like, if I roll the dice and then I picked a card from a deck, there's nothing in common from them. Some events are always independent, like gender of a baby, like rolling dice, flipping a coin. One does not affect the other. So first we have to look to see if these are going to be dependent or independent. So looking at the second thing, does it depend what happened here to say this? So rolling a numbered cube and spinning a spinner. Well, there's nothing in common in those, so those would be independent. You should look up a song with Beyonce, Independent, great song. You pick one flashcard, hold on to it, then pick it from the same stack. Because it says you hold on to it, you do not replace it, you do not put it back. This would be dependent. Because once you take out one card, that's going to change the total number of cards that you have. Pick one flashcard, replace it, reshuffle, pick another one. These will be independent because I'm keeping the exact same number of flashcards in the pile. Select a coin at random from your pocket, replace the coin, and select again. When you replace the item, these are going to be independent events when you replace the item. And last one, flip a coin, then flip the same coin again. Well, the coin does not change when you flip it from one to the other. So these, again, would be independent events. When you have independent events, you know that they're independent. Whenever you see an and statement, actually, whenever you see an and statement, you're going to be multiplying. And multiply. Multiply the probabilities of each event together. So if I look at this right here, so saying you have diet drinks, you have regular drinks. You have fat-free chips, you have regular chips. So it's saying without looking, you pick a drink, you pick a chips. What's the probability you will get diet and fat-free? And. So one does not depend on the other because there's no overlapping in between drinks and chips. So we have to figure out the probability that you could pick a diet. So if I look at my total drinks, I have 15 total drinks here. 10 of them are diet. So I have a 10 on top. And so I'm going to be multiplying. What's the probability that I get a fat-free chips? So I have 8 fat-free chips. And together I have a total of 20. And I multiply straight across. So I would get 80 over 300. Or you can type this into your calculator. 10 divided by 15 times 8 divided by 20. Change it to a fraction. Either way, you should get 4/15. If you want to keep it as a percent, it'd be 27%. That's the probability you get diet and fat free. What's the problem? I'm going to pause and I want you to answer this next question. So you have 5 options here. You have 12 options here. You multiply them across because both of these have to occur. And that'd be 1/5 or 20% chance. You cannot just subtract this because you could get a diet and then a regular. You could get a regular, then diet. So there's more than just these 2 options that you have. So now we're going to get into mutually exclusive. 2 events that cannot happen at the same time are mutually exclusive. So if they're mutually exclusive, then when it has an and here, it would be 0%. They can't happen at the exact same time. So you roll a standard number cube. Are the events mutually exclusive? Explain. You roll a 2 and a 3. Well, these would be mutually exclusive. I'm going to put an ME, mutually exclusive. Why? Because on a number cube, you cannot roll both at the same time. You cannot roll both at the same time. Rolling an even number and a number multiple of 3. So when you're looking at this, are there any even numbers? So if I'm rolling a number cube, 3, 4, 5, 6. Even numbers are here. Multiples of 3 are here. So this one overlaps. So these are not mutually exclusive. not mutually exclusive because 6 is even and a multiple of 3. I want you to pause. I'm going to pause the video. I want you to try to do the next two by yourself. C would be not mutually exclusive because 2 is both even and prime. So that is true for both. Since there's an overlap, then not mutually exclusive. This would be mutually exclusive because it's even or less than 2. 2 is not included here. So the only number that's less than 2 would be 1. So that is not even. So these would be mutually exclusive. Our last little bit from this section is if we have one event or another event occurring. So whether the events are both happening at the same time are mutually exclusive. So when you have an or, you're going to be adding, or you should be adding. However, you might have to take away wherever they overlap, okay? If they're mutually exclusive, if they have nothing in common, then there's nothing that you have to subtract. So let's look at this question right here. So it's saying that you can either take a foreign language, 37% take Spanish, 15% take French. It does not say anything about someone taking Spanish and French. So there's no overlap. At least we have to assume that there's no overlap. So since there's no overlap, we are going to take the 15% and add it to the 37%. And we get 52%. 52% are taking Spanish or French. I want you to try to do the next one by yourself. So at 18, choose woodworking. 38, choose music. Probability to choose woodworking or music, you add those two together. So now if we look at this is a little bit different. Suppose you're looking at this dish. What's the probability a token is round or green? Well, we can't see colors right now. Okay, so now I actually have them labeled with the color that they are. So first, actually, before I do anything else, I'm going to count them. So again, when I count, I put little tick marks so I remember that I counted it. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my total, I have 9. What's the probability that a token is round or green? So there's two ways that you can do this. So if I look at how many are round, I have 1, 2, 3, 4, 5. There's 5 out of 9 that are round. So I'm just looking at my round. Or, so I'm going to be adding how many of them are green. I have 1, 2, 3. I have 3 that are green. So plus 3 out of 9. Because, again, if they're not mutually exclusive, you have to subtract where they overlap. So if I have ones that are both round and green, so if I look at the ones that are round and green, here's a round green and here's a round green, then I have to subtract the overlap. So there's 2 that are both round and green. So here's round, green, subtract round and green. Now this is one way that you can do it. Here I have 8, take away 2 would give me 5/9. Another way I could do that is looking at the ones that are round, making sure to put a mark by them. So here's a round, 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 round. Now if I look at my greens, the only one that I have not counted yet is this one. So now if I clearly look, I can have 1, 2, 3, 4, 5, 6. Oh, I'm supposed to have 5. And I don't have 5. I must have did one of these wrong. So I have 6. 6 that either are round or green. I have to check this. Round. 1, 2, 3, 4, 5. Green. 1, 2, 3. I must have counted wrong here. So I have 6 out of 9, which, because 5 plus 3 is 8, 8 take away 2 would be 6. So this is where I did my math wrong, which is the same thing. Divide both of these by 3, and I get 2/3. Divide by 3. So I could either count them, or I can find round, green, subtract round and green. So I'm going to do one more here, and then you're going to do this one by yourself. So probability of token is square or red. So if I look at my squares, square, square, square. There's 3 that are squares. So 3 out of 9, plus the ones that are red. Here's red, red, and red. There's 3 that are red. Now I have to subtract the reds that are squares. So if I look, here's the only one that's red and squares. So I have to subtract 1/9. So 3 plus 3 is 6. Take away 1 would be 5 ninths. Again, or else you could just count. Okay, here's my squares, and then look at the other two reds that I have not counted yet, still would give me 5. I want you to try to do C by yourself. So green, I put a star by green. Now I'm looking at my squares. I'm only going to put the star by the squares that I have not counted yet. I already counted this one. So now I'm going to put a star, put a star. So now I'm counting all my greens and the stars here. So now if I count 1, 2, 3, 4, 5, I'll get 5 ninths. Again, you still could have found how many of them are green. So 1, 2, 3 ninths. Added the how many are squares, 3 ninths. And then you have to subtract the one that is both green and a square right there. So 1 ninth. Either way, you should get 5 ninths. And there you have it. Probability, mutually exclusive, independent, dependent. You're amazing. Have a great day.